All right. Homework questions. Number 7. Number 7. F of x is 3x squared minus 2 cosine x. You having trouble with the derivative of cosine? Oh. All right, so we'll talk about it though. You're trying to find the derivative of 3x squared minus 2 cosine x. So we have two terms, right? You can say that these two terms are separated by subtraction. So the rule with derivative is that you can do the derivative of each one separately. And that was given to us with this rule number 5. If you have two functions added or subtracted, you want to take the derivative, you just do a derivative of each one, add or subtract. So when I look at this, I now need to focus on 3 times x squared. 3 is a constant attached to a function with multiplication, so what do I do with that 3? Just bring it with me, right? So here's 3. Then I say times, now the derivative of x squared. So this is where we use the rule. The 2 comes out in front. Subtract 1 from that power. 2 minus 1 is 1. That's your derivative right here. That's just 6x, isn't it? Now we have, let's see, we have a minus and then a 2. That 2 is attached to a function, so I'm going to bring it down. Minus 2 times, now the derivative of cosine x, which is in your notes. The derivative of cosine x is negative sine x. So I'm going to have times, I'll put it in parentheses, negative sine x. The reason I'm going to put it in parentheses is because I'm doing a negative 2 times a negative 1, which becomes plus. So my end result here is 6x plus 2 sine x. Good? Other questions? 19. Yes. Y equals square plus 4x plus 3 over square root of x. Why does it keep doing that? So we discussed this last class that we are still very limited on what we can do as far as derivatives. We have to have x's to powers to do the power rule. We do have x's to powers, but we have this quotient, this fraction. And you are not allowed to take the derivative of each one on top, then divide that by the derivative of what's on the bottom. You cannot do that, unfortunately. So the only thing we have an option to do here is to maybe take these 3 terms, split them up, put each one over the common denominator, which is what I'll start with. So I'm not doing any calculus right now. This is just algebra. I'm also going to rewrite the square root of x as x to what power? 1/2. Plus 4x over x to the half plus 3 over x to the half. And now I need to figure out what those are. So when you do this, right here, we're using a property of exponents that said this. I'm writing it on the side. If you have x to the n divided by x to the m, that is equivalent to x to the n minus m. So you subtract the powers. So you're going to take 2 and you're going to subtract 1/2, which is subtracting 1/2 from 2. 3/2. So your result here is an x to the 3/2 plus. Now the 4 is going to be here, right? Because I have 4. So here's 4. And then I'm going to try and do x to the first power, right? That's what this means. X to the first power over x to the half power. So again, same property. 1 take away a half is a half. So you get x to the half. Then I have plus. This 3 is on the top, so I'm going to write 3. Now what about this? You could do that, but you can also just use a property that you can just bring it up to the top. Next, x to negative 1/2. Right? So back in the day, you were told this in another class, hopefully. X to the negative n equals 1 over x to the positive n. So if you had a negative power, they always told you, hey, drop it down, right? Well, now we want to actually reverse that and take it back up because we want to be able to do the power rule. Okay, now we're ready for the derivative. So this is y. Now, how do I say the derivative? I could use 2 different notations, or 2 common notations. I could say y prime. Another notation you might see is dy dx. Both of these notations are the same. Those both mean take the derivative of this. So let's do some power rule. Power here is 3/2. That comes out, right? 3/2 in front. X to the, take 3/2, subtract 1. 1/2. Next one, plus, here comes the constant, just leave it, times derivative of x to the 1/2. This comes out 1/2, right? That'll hit the 4 and become a 2, yes. X to what power? Negative 1/2, because you subtract 1 from a half. Then plus 3 times, now do the power rule here. So the negative 1/2 comes out in front. X to subtract 1 from negative 1/2. Careful there. Negative 3/2. Good. That's it. We got to clean it up, but that's it. Does that address the question? Yes? We could just leave it like this. 3/2 x to the 1/2 plus 2 x to the negative 1/2 minus 3/2 x to the negative 3/2. We good with that? Okay. Any others? It's going to look totally different, yeah. Okay, so let's just take a little time to do, let's match the back of the book. Okay, so what does the back of the book say? Oh, wait, hold on. Can you just bring it over? Let me see. What I'm going to do is I'm going to show you, this is a good exercise for all calculus students, is to try and get your answer to match the back of the books. It's a good exercise in algebra. That's the answer in the back of the book. Right? Mm-hmm. We like to, but we also should be comfortable getting it to this. So our answer was this, right? I'm not going to do this for each problem. I just want to show you at least one time the algebra that's required here. First of all, x to the 1/2 means what? Square root of x. And then the 3/2 in front. So that is this, right? Okay, this is a 2, x to the negative 1/2. So you could rewrite this as 2, and then the negative 1/2, you could drop that down as a positive 1/2, couldn't you? So that's what this is, right? That's what this is. But what is x to the 1/2? Square root of x, so that's this. Yes? This one, negative 3 over 2, what they decided to do here was to write as negative, here's the 3, the 2's on the bottom. They brought the x to the negative 3/2 down like this. Y'all see this? So leave the 3 on top, the negative is just going to come out. The 2's on the bottom, and then they brought this down with it. Now what does this mean? That means x cubed square root, which means x squared times x, right? You could write it that way, which is the same as the square root of x squared times the square root of x, because if you have two things being multiplied in a root, it's the same as splitting it into two roots. The square root of x squared is x, so this is x root x. So x to the 3/2 is the same as x root x, which is where that comes from on the bottom. So I challenge you on your test, or on your homework, to get your answer and then try and make it look like the back of the book, because you will sharpen your algebra skills tremendously if you do keep that up. It reminds me when I was at UTSA teaching a calculus over there. We had these things. Actually, I was teaching it's a weird thing. It's once a week. The students all go to a room and to ask questions on homework, and so they put someone up in the front of the room to answer questions, and that was me. So I just would walk in this room with like 100 people and be like, "Any questions over the homework or over whatever?" And that's when you have to be good. Like, you have to really be comfortable with it, because they can give you anything, right? So I went through a problem and I worked it out, and I got it to basically something like this. All right. Now, not this simple. It's more complicated because we're about to start doing these. And I left it at that. I boxed it and I went on. Well, this guy in that session came and like tracked me down, like busted through the like tutoring lab doors, was all pissed off, like totally embarrassed me in front of all these people who were there getting tutoring, was like, "You put the wrong answer on the board," and la 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 la, and here it is in the back of the book, and they're not even close, and all this stuff. And I was pissed because he was trying to humiliate me basically. So I made him sit down, and I told him, "Sit down, and I'm going to teach you some algebra." And so I showed him how to transform my answer into the book. And so that is an exercise I think you should do, because you'll get an answer, you'll be like, "I think I'm wrong. It doesn't look anywhere close to the right answer," but it most likely is the right answer. You just haven't done enough algebra to get it to look like the book. That guy was an ass. I think he just kind of just walked out. He was mad that it was right. I don't know. He had something against me. I don't know what his deal was. I think because I was much younger than him at the time. Okay. We are moving on. Product and quotient rules. I think I've addressed a couple of answers, right? Did you look at the notes for this? No? It's that. That's it. This is it. This is it right here. All our rules up to this point have been straightforward, right? I guess. The next two are not. So you can write this down if you want. It's in your notes, whatever. I'm going to present this kind of in a different manner. Here it goes. Product rule. So the question now becomes, what do you do if you're trying to take the derivative of something where you have a product? And we do not mean like this one right here, 3 times x squared. Because this is a product, right? Do you agree this is 3 times product, x squared? This was simple. The 2 came down, right, and it was done. What we mean is, what if you have something like sine x times the square root of x? Something like that. Now these two things, like, you can't ignore one, or you can't just bring one down and do the other one, right? Like we did with the 3 and the x squared. These are 2 functions of x, aren't they? 2 functions of x. This one right here is a function of x. This one right here is a function of x. I'll call it g of x. We are multiplying these 2 together. And we want to know what happens if we take the derivative. What do we get? Well, there is a rule, and it's a formula, and you have to memorize it. It is the product rule. Here's what it says. So this is the big question. What's the derivative of this? So the rule says this. If you have a function, I'm just going to write f instead of f of x. F, and you're going to multiply it times some other function g. And you want to take the derivative. That's what that little prime meant, right? Take the derivative. We comfortable with this? That this will be equal to, let me show you what you wish it was equal to. You wish it was equal to this. That's what you wish it was, right? Because that would make life easy, right? You take derivative of each one, multiply them together, you're done. That is not what it is, though. It is actually the derivative of f times g. So you have to take the derivative of f first, then multiply times g without taking the derivative of g. Once you've done that, you add to that the derivative of g times the f without taking the derivative of f. That's the product rule. And you need to memorize it. I'm going to not prove that that's true, all right? I'm not going to prove it. If you want to, you can come to my office, and it's really an awesome proof. Like, it's not even a proof, but the way you do it is really, really clever. So here we go. Let's practice with this. That's all we're going to do is do product rule and quotient rule today. So I'm going to do a couple problems. You're going to do a couple problems. So here's your first example. How about if y is equal to x squared times sine x? Well, you know, I normally would not write that dot between them. That's too much. I'm giving you too much information there. Find y prime. Is everyone comfortable with the fact that that's a product? Right? I always like to identify where the product is, and I like to do it by just drawing like a little vertical line right between where the product is, like that. That's where my product is occurring, yes? Is there a product right there too? That's sine times x? No, it's sine of x, right? It's a function, so no, that's no go. So if I wanted to, I could like think of my x squared as my f and think of the sine x as my g, yes? You could flip them. Yes, it is commutative, so it wouldn't matter. What you could not do is make this sine of x cubed, right? You couldn't try and put that x in there with the x squared, or the x squared in there with the x. Okay, so let's see. The derivative then should be, I'm just going to write in red above this, f prime g plus g prime f. That's what I need to write down on the next line, right? So let's see if you are comfortable with this notation. I'm going to go very slow on this one. F prime. F for us is what? X squared. So I'm going to write x squared, and then its derivative, right? That's what F prime would mean? Times G, right? So times sine x plus G prime, which would be the derivative of sine x. So I'm going to write sine x with the little derivative thing on it, times the F, which is x squared. Try and line things up. That. Everyone follow the formula? Okay, so this is now, let's take some derivatives. We haven't taken any derivatives yet. What is the derivative of x squared? 2x. That's using power rule, right? 2x. And then you still have sine x next to it. All right. What is the derivative of sine x? Cosine x. But there was a plus here, wasn't there? So plus cosine x times what was here? X squared. Can I put this x and x squared together? No. So what should I do with this x squared so that no one gets confused? Move it in front of the cosine. That's just standard notation. 2x sine x plus x squared cosine x. Box it up. I don't think there's a whole lot more we can do with that. That's a pretty complicated derivative, isn't it? I mean, considering it just came from this, and it turns into this nasty looking thing, right? Questions? Well, I'd have to prove it if you want me to prove it. We'll take a vote. You have to use your hands because I don't have clickers today. How many of you want to see that the proof that the product rule is what it is? Kind of want to see? Okay. Man. It's going to take 15 minutes. You can't come to my office? Okay, well, let's do it. I'll do it in the office or something. Yeah. We'll keep going. All right, so let's try something else. How about y is equal to square root of x tangent x? All right, so I'm trying to find y prime. What do you see here? You see a product there? See that product? You see the F, you see the G? So our derivative should be, and we want to be able to start saying this in our, in our sleep. F prime G plus G prime F. F prime G plus over and over. F prime G plus G. F prime G plus G. That's, I mean, right? Okay, we don't want to have to refer to a formula sheet for it. Now, if you look in the book, the formula is going to look a little different. They changed the order of stuff. Just trust me when I tell you that if you memorize that one, life will be a little bit easier, all right? F prime G plus G prime F. So, let's see if we can do this without having to, like, write down the primes. Or did y'all like that? Did y'all like it when I did that? I need to slow down. I need to be compassionate here. Square root of x derivative, right? That's our f prime times g, no derivative, plus g prime, which is my tan x prime, and then times square root of x. So we have f prime g plus g prime f. That's what it is, right? You can sing it, you know, whatever. If you play guitar, go for it. Okay. What is the derivative of the square root of x? 1 over 2 root x. That's the one I told you it needs to be an automatic one. So 1 over 2 root x, good, very good, times tangent x plus, what's the derivative of tangent x? Secant squared x. How do you know? I told you, and I gave you a list in your notes last time, and I told you to remember those, right? I'm sorry? You'll have formulas, yes, you will. You'll have the common derivatives. Secant squared x is one of the common derivatives. Times what? Just the square root of x, no derivative, right? That's it. Now what we could do is try and simplify this possibly. I don't think there's a whole lot we could do. We could maybe put this tangent x on top of this, and that's about it. I mean, you could get fancy and try and put these together with a common denominator. You could, but it's not incorrect here, okay? All right, let's try something else. So far, does this seem okay? How about this? Y equals x to the negative 1 plus 4x minus 7 times x squared minus 2x cubed plus 1. So we have to be very aware of what's happening here. If this whole thing right here wasn't here and it was just these three, you would take the derivative using what? If it was just these three pieces, just do power rule, right? Negative 1 would come down, subtract 1, right? Derivative 4x would be, what's derivative of 4x? Would be just 4. Derivative of negative 7 would be 0. That's what we would do if this wasn't here, but it is there. So what it does is it creates a product, doesn't it? Now we could expand this all out, like multiply it all out and get one big string of things, right? But I'm going to avoid that by using the product rule. I'm going to use the fact that this could be called f and that's g. That fair? So my derivative should be the f, right, prime. So here's f. I want to take its derivative times the g, which is that whole thing, plus the derivative of g, so I write down g with a little prime mark on the outside, times f, which is this. Questions? It's just the formula. No derivatives have been taken, right? Just the application of the formula. Now here comes the derivative. And what is the derivative of this? Well, you have 1, 2, 3 terms. So you just take derivative term by term, differentiation, using power rule. So what's derivative of x to the negative 1? negative 1, x to the negative 2. What's the derivative of 4x? 4, so I put plus 4. What is the derivative of negative 7? 0, so I don't need to put anything. Close off the parentheses. That's the derivative of f times g. So here's g. Not touching g, right? Leaving it alone right now. Then plus, now the derivative of the g. So I'm just going to highlight in here the two things that we are taking derivatives of. Stuff that's not highlighted, we're not touching, right? Okay, so what is the derivative of that one? 2x minus 6x squared. And then the derivative of 1, 0, so nothing. And then just tack on to the end of that whatever that g was, or I'm sorry, f was. So again, f prime g plus g prime f. F prime g plus g prime f. At this point, you know, leave it, multiply it all out, simplify, try and match the back of the book, whatever. You know, on a quiz, I'm not going to ask you to simplify this because it's just going to waste time, all right? Just want to make sure you can apply the rule, all right? Well, yeah, if you have to take the second derivative, then you would have to do the derivative. Look, there's a plus, right? So you do derivative of this one plus the derivative of this one, wouldn't you? The derivative of this one would be another product rule, plus the derivative of this one, which would be another product rule, different one. So it'd be two different product rules you would apply there. Yeah, so you would have 4 on the next one. Yep. What I remember last class, we had a discussion about why didn't you just give us the rules, right? And I said, be careful what you wish for. I think you can kind of see how complicated things can get, how quickly it can become complicated, right? Yes. So I'm curious how you'll handle this. I want you to find y prime. Now I'm going to put a little asterisk on this, okay, or star, whatever. I want you to just be aware that we are going to have an easier way of doing this later. Much easier than what I'm about to do. But I want you to see how the product rule can be applied. Do you have a question? No? So your instinct might be to do that, and that's a good instinct, that the 3 comes down, right? And then you just make that a 2, and you're done? Almost. There's more to it than that. And that's going to come after this next section. What we're going to do is called the chain rule, and we'll be able to do it that way, kind of. But before we get chain rule, we have to get product and quotient rule down, and we have to be good at it. So here, watch the way I'm going to do this. First, I'm going to write this as x squared plus 1 times x squared plus 1 times x squared plus 1, because that's what it means to cube something, right? Now, do we have product? Yes, but we have three factors, don't we? Instead of just 2 things being multiplied, it's 3. So I'm going to choose to split it right here, okay? I'm going to call this one up here f and this one up here g. Does that sound fair? G, though, actually contains what? 2 pieces, doesn't it? Doesn't it? Okay, that's going to be critical. Let's look at what the derivative is. The formula says I should have f prime. So that should be the x squared plus 1 with a little prime mark next to it. All right, that's f. That's the derivative of f. Times what? G, right? This whole thing. So I've got x squared plus 1 times x squared plus 1 again. You could write squared. I'm just going to leave it like that for now. Plus, now what? G prime, right? The derivative of all of this. I'm going to put that in red. I want the derivative of all of that stuff. That means I need the derivative x squared plus 1 times x squared plus 1. Right? I need that derivative. Then times what? After I figure out what that derivative is, times what? X squared plus 1. Okay, does everybody at least agree with the format? We have f prime g plus g prime f. Any questions? Are you going to have any trouble finding the derivative of this? What is the derivative? 2x. Are you going to have any trouble finding the derivative of this? What are you going to have to do? You're trying to find the derivative of what? A product. Well, guess what you get to use to find the derivative of a product? A product rule. But it's got to be on the side and it's got to be scratch work. Do y'all see that? So this right here just created its own new problem, doesn't it? That's why I wrote it in red. That's going to be its own little problem on the side. So how about I do that right here? Just try and keep it all on one page. If I were to start a problem out and say, hey, what's x squared plus 1 times x squared plus 1, and I want to find that derivative, you apply the formula. It would be f prime g plus g prime f, right? Here's where we're splitting it. This is my f. This is my g. Do y'all follow what I'm doing here? I mean, I had a product rule, but then within that product rule, I have another product rule. Be careful what you wish for, right? So now, what is that? Let's write it down. It's going to be x squared plus 1 derivative, right? Times x squared plus 1 plus x squared plus 1 derivative prime times x squared plus 1. Now go ahead and take your derivatives there. I think those derivatives you can handle. Derivative of x squared plus 1 is just 2x times the x squared plus 1 plus derivative of x squared plus 1, same thing. 2x x squared plus 1. What happens when you take 2x times x squared plus 1s and add it to another 2x times x squared plus 1s? You get a total of 4 of them, right? Look. What's in blue there is an iPod. iPods? People don't use iPods anymore. iPads, iPhones, whatever. 2 iPhones plus 2 iPhones is 4 iPhones, right? Well, no one said 4. I didn't hear anyone say 4, so I'm just making sure we're comfortable. This is 4x x squared plus 1. I didn't hear anyone say that. Did anyone say that? Yeah, I didn't hear it, so sorry. I'm adding 2 and 2 together. I get 4. Just add the coefficients, right? 2x plus 2x is 4x, except this is 2 blue plus 2 blue is 4 blue. Hey, look, that's the derivative of this. So that thing up here, right, this, when I come back up here and do this, that right there is going to turn into that, isn't it? So I'm ready to roll. So back up here, this is, take my derivative right here. What do I get? 2x, and then I had x squared plus 1 times x squared plus 1 again, right? So squared. I'm going to do it now. And then this red piece turns into this. So I have, and then don't forget the plus sign between them, plus 4x x squared plus 1. What's still tacked on to the end of this at x squared plus 1? Whew. All right. Oh, and that's squared then, isn't it? So I have 2x times x squared plus 1 squared plus 4x times x squared plus 1. Can you simplify that squared? These are, again, exactly the same, aren't they? 2 of these plus 4 of these is 6 of them. And that is the end. That's your derivative. Now, I don't mind looking ahead, okay, to chain rule, the suggestion of the 3. I want to show you how easy this is going to be later. And don't ask me then why did we do this, okay? This is just to get you to see that it's possible to have to do a product rule within a product rule. That's fair game. All right, so you were suggesting that we take this and we just act like this thing right here, just act like that was almost like an x, right? What's the derivative of x cubed? It would have been like 3x squared, but that is obviously not the answer down here, right? The x is the x squared plus 1. This does not say 3 times x squared plus 1 squared. We've got this 6x out here instead, right? So let me show you where it's going to come from. Your thought was that this might be 3 times x squared plus 1 squared. That's what you were thinking? That is correct. But now what you do is you go inside. After you've done the 3 comes out and you've subtracted 1 and rewritten this, now on the outside you tack on the derivative of what was in here. What's the derivative of what's in here? 2x. Now, when you put this 2x over here with this 3x, what do you get? 6x. That's this. Much easier, right? We're just not there yet. So just at least feel good in that there will be easier ways to do that later. I would never ask you to do this problem with product rule. Yeah, I would never do that. But it's a good, like I said, it's a good illustration of product rule within product rule. All right, next. How about I give you a few? Yes? Practice? And this book is just not robust enough with questions with product rule. So you try. Y'all can work together or talk to each other. Let's take like no more than like 10 minutes to do these 2 problems. Practice like being neat, okay? We're not here to run speed tests. All right. You should have, for your derivatives, y prime on the first one. Let's read it out. Come on. Ready? Just the final answer. Not factored or anything, just the raw 3x squared. Okay, if you put the x cubed first, that's right. Secant x tangent x. That's good. That's the first one. Everyone got that? Okay, next one. You had 2 product rules. You had to do separately and then add the answers together. So go ahead. Cosecant x minus x cosecant x cotangent to x. Then here's your plus. Now we're moving on to this one. So product rule here, derivative of x is 1 times this plus the derivative of this, which is negative cosecant x cotangent x, times x, bring the x up front, change the plus to a minus. Over here, 1 over 2 root x, cotangent x, minus square root x, cosecant squared x. Done. Any questions? Everyone got that? Everyone has that? Yes? And we just leave them like that. I mean, think about what you could do. You know, you could possibly try and group things together, factor things out. I mean, that's down the road, perhaps. All right, so that is the product rule. All right? Now let's look at the quotient rule. So we just saw, I'm gonna write the product rule up here again for you. That's product rule. Here's what the quotient rule says. If you have a quotient, f divided by g this time, not multiplied, that this will be f prime g minus g prime f. That looks familiar? That's the product rule, except subtraction instead of addition, with one other thing. All over g squared. No derivative, just whatever the function g was, squared. That is your quotient rule. Now, this is where I want to try and explain something. Who has the book? Anyone have the book that I... No, you don't have to dig it out. Someone has it on their desk. I want to show you what the book does because I'd like to discuss it. When you get to 2.24 in the book says their product rule is this. Fg prime plus Gf prime. Now, is that the same answer as what we have? Yes. They just switched the order, right? Like the addition. So f prime g, that's this, plus, so there's their plus, g prime f, they have fg prime. So it's the same thing, right? Just kind of rearranged. Okay, and then for quotient rule, they have this. Gf prime minus fg prime all over g squared. That's the way most books do it. No, thank you. So why is it that I showed it to you the way I showed it to you? I think it's easier because it's really the same formula, except there's a little minus here instead, and you divide by g squared on the quotient, right? It's the only difference between these two. But if you look at these two, they look like completely different animals, don't they? I mean, like fg prime plus gf prime. This one's gf prime minus fg prime all over g. So you have to, like, these are different orders of everything. Do you kind of see that? So it almost seems like you're learning two completely different formulas. When you look at it this way, it's really one thing. You got to remember the minus and divide by g squared on the quotient. That's all you have to remember. Make sense? So whenever I'm grading stuff, I can always tell. I can always tell people who have gone to get tutoring or someone who's, gone back and looked at the book, because they'll most likely be using one of these formulas. Then I'll realize, okay, well, they're not really using what I showed them in class. It's not wrong. It's just I can identify that pretty easily. All right. Shall we apply the rule? All right, let's do an example. Here's y equals. Now, this really opens up the possibility and the complexity of things. Okay. What's the derivative of this? Listen, I'm not trying to make things weird here. Just what's the derivative? Secant squared x, right? I wonder why. I wonder why it is secant squared x. So let's see why it's secant squared x. Because tangent from pre-cal is really sine x divided by cosine x, isn't it? And I can look at the top one as f and the bottom one as g, couldn't I? And then I could apply the quotient rule. The quotient rule says that the derivative of that should be f prime, which is the sine one, right? That derivative times the bottom one, the g, what? Minus g prime, right? Which is the bottom one, derivative times f, which is the top one. All of this divided by the cosine on the bottom squared. Okay, that is the application of the quotient rule onto this quotient. F being the top, G being the bottom. We comfortable with that? Now, what is the derivative of sine? Cosine. Now, you might ask, well, why is that true? Well, I proved it last class. I did the limit and I showed you. We had to use do you remember me doing that last class? I had to break out an identity, a sum identity, and I did it. You can go back to your notes. So I can prove to you that the derivative of sine is cosine. And I could also prove that the derivative of cosine is negative sine. But I'm using those here. Derivative of sine x is cosine x. So let's see what happens. We get cosine x times cosine x again. Then minus, what's the derivative of cosine x? Negative sine x. So I'm put a parentheses there. Times that sine x again. All over the bottom squared. Can I rewrite that like this? Using that other notation? Cosine x squared really means this. What's this here? Cosine squared x plus sine squared x. And you should have this very small little aneurysm occur. I'm sorry. Maybe someone knows someone who really had an aneurysm. I'm making light of it. But you should have this little light bulb go off in your head. Cosine squared x plus sine squared x is 1. That's the basic Pythagorean identity from pre-cal. So this is equal to 1 over cosine squared x, which is the same as secant squared x. So if it seems weird that the derivative of tangent to x is secant squared x, you can show that it's that by using the quotient rule. You don't have to, all right? I just wanted to show you where it came from, and I knocked out 2 birds with 1 stone there, right? Showed you an application of the quotient rule and where derivative of tangent comes from. It's a cool exercise. I don't know, depends on your definition of cool. To go and verify all the other ones, like show that the derivative of secant is what? Derivative of secant x is secant x tangent x. To go actually do that using quotient rule. How would you do that? I'm not going to do it, but how would you do it? If I want to show the derivative of secant x, I would turn it into 1 over cosine x, and the top would be f, right? And the bottom would be g. Yes? Question, what's f prime? 0, right? So it'd be f prime g minus g prime f all over g squared, then you'd simplify, and at the end you'd get secant x tangent x. Okay, that's just for your own fun if you want. Let's see some other quotient rule. X cubed minus 2x plus 1 over x squared plus 4x plus 5. Can I make that a minus 5 at the end? Thank you. Appreciate that. Let's take a step back. College algebra. What type of function is that? College algebra. That's a far step back. Maybe too far. What is the top by itself? X cubed minus 2x plus 1. What type of function is that? Polynomial? You divide a polynomial by another polynomial. That's called a rational function. Do you remember the graphs of rational functions? They're like weird asymptotes and stuff, and yeah, maybe not. Well, if we were to graph this, we might want to know what the slope of the tangent line is at different points, which means we'd want to know what the derivative of it is, and that's what we're doing right now. We're finding the derivative of something like that. So does everybody see quotient rule here? F top, G bottom. Can you do what we did on the first problem that was asked today in the homework? Can you approach it this way? Now here what we did is we had to take this, divide by this, this over this, this over this, right? We split it up. The key to that was there was only one term in the denominator. Here we have multiple terms in the denominator. We cannot do it that way. It's not going to work out nice. So we would have been stuck with this had this been the beginning of class. We would have not been able to do that. But now with the quotient rule, we should be able to. So let's write down our derivative. The derivative should be the derivative of f, so x cubed minus 2x plus 1, that derivative times the g in parentheses, then what? Minus the derivative of what? G, so I'm going to put the G there. I'm going to put the little prime mark on it, times f, x cubed minus 2x plus 1. All of this over, my gosh, all of that over, division bar was long, right? And x squared plus 4x minus 5, that quantity squared. Yay, we get to take derivative. That's just the setup, now derivatives. So I'm going to take derivative here. What is the derivative? Oh, notice my use of parentheses. You cannot get away with just leaving off parentheses. Like, for example, look at this first one. Take the parentheses off right here. See that? That is totally incorrect, because what you're saying here is it's the derivative of this, right, times what? Times x. That's it. Just x. Not this stuff. It's not attached anymore. When you put parentheses, you're saying it's the derivative of this times this entire quantity. I'm missing squared there. Was it there to begin with? Okay, I must have accidentally erased it or something. Okay, derivative there, top left corner, is what? 3x squared minus 2. Anything else? Put in parentheses? Yes. And then the next piece, which you don't do anything with, minus, now I need another derivative. 2x plus 4, and then x cubed minus 2x plus 1. Don't change that one. All over the bottom squared. I refer to this as the raw derivative, okay? That is the unsimplified, just right after the formula, you take the derivatives, that's what it looks like. That's usually the first thing I look at on a test, is to see where your raw derivative is. And sometimes on a test, I will tell you, because of time, just give me the raw derivative. Don't go simplifying it. And we could, multiply all this out, right? Multiply this all out, collect like terms, and that would be a more simplified version, wouldn't it? So I'm going to stop here, with the idea that you could do that multiplication and simplification. So remember this. Seems like ages ago. This is the what? That is the definition of the derivative, right? That is the limit definition of the derivative. We are not using that anymore because we have all these nice rules. But just for appreciation here, I would like you to take a look at what it would be had we not had the quotient rule if I would have asked you for the derivative of this using the definition. It would have been y prime, the derivative would have been the limit. Hey, don't write this down. H goes to 0. F of x plus h cubed minus 2 times x plus h plus 1 over x plus h squared plus 4 times x plus h minus 5 minus f of x cubed minus 2x plus 1 over x squared plus 4x minus 5, all of that over h. Okay, so get a common denominator and go to work, right? You see what I'm saying? You see? Like, that's the power of a rule in math, is that once you prove the rule is true all the time, then you can take a problem like this and you can totally go around all that algebra, right, by applying the rule. I would not want to do that. That would be punishment for somebody, right, to have to do that by hand. All right. More quotient rule? How about this? Yeah, you see that the top is a product? You see that, everyone? Okay, but we need to get everything in the correct order. We still have, as an overriding theme here, a top and a bottom, right? An F and a G. Now, the fact that my F is a product, I will deal with, okay? I'm going to deal with that. But I have an F over G, yes? According to the quotient rule, the derivative of that up there should be the F prime, so x sine x, whatever that derivative is, times the bottom, minus the G, but its derivative, times the F, all of this over the G squared. I'll let you finish. Any questions on that? This derivative right here does not present an issue, does it? X squared plus 1? All right, that's just 2x. The derivative here, what about it? It is a product, which means you will have to apply the product rule on that before you go replace it. So you need to go to the side now and do some scratch work. So on the side here, SW, scratch work, I have x sine x. I want its derivative, which should be, this is all going to come down to now how fast can you get with this. Do you have to write down each time the primes? It's going to depend on you. I'm going to work that one a little faster. We have the product rule right there between the x and the sine x. So the derivative is sine x, and then it'll be plus x cosine x. Where at? Like into the cosine? No. Mm-mm. Nope. Well, you could, but it would be wrong. Any questions? This right here represents this entire thing, right? The derivative of it. So I'm ready. I'm ready to write the answer here. Y prime should be sine x plus x cosine x times x squared plus 1. Is that correct? No, I need parentheses around that whole thing, right? So that became this. This is just this minus 2x times x sine x. That x and that x can go together to become x squared. That's okay. All of this over x squared plus 1 squared. That's our raw derivative right there. We okay? Maybe one more example. Just like anything else, you're going to have to just go and practice. A, B, C. So what have we said about the letters A, B, and all that stuff in this book? What do we refer to them as constants, don't we? Right? Like A, B, C in the problem. The assumption here is that x is our variable, right? Everything else is just a number we don't know. Anything? Any suggestions? Do what? Do this? Quotient, LCD. There's all these things are correct. I mean, everything that I've heard is pretty much okay. Overall, though, do we see this? F and G? F over G. Do you all see that? F over G. So if I can figure out the derivatives of each of those, then I should be in business. But the F here, this should be, let's see, if I had to take the derivative, which I'm going to need to, can you tell me what the derivative of AX is? A, right? What's the derivative of 5x? 10x, 10, right? So derivative of AX is A. This presents a little bit of a problem, right? Because the x is down here. Could you use a little quotient rule on this one? Yes. Is that the most efficient way to do it? No. The more efficient way to do it is just to bring the x up with the b and make it an x to what power? -1. That you can use the power rule on. and avoid the quotient rule. Same thing here. The negative b, what's that? After the derivative? Negative bx to the negative 2. But we'll get to that. Same thing here. Derivative of cx will be c, and then this one I can bring the x squared up as an x to the negative 2. So let me rewrite the problem first, because I think I will enjoy it a little more if I don't have all those fractions or things that look like fractions. All I've done is some exponent properties. That's it. And now I'd like to, again, identify my f and my g. And when I'm doing this, I'm kind of thinking, am I going to be able to do those derivatives? And at this point, I feel comfortable that I can do these. So I'm going to proceed with the quotient rule. So my derivative of y will be equal to f prime, that's ax plus bx to the negative 1, that derivative, times g. What's g? Cx minus dx to the negative 2. Then minus the g1, cx minus dx to the negative 2, that derivative, times the f, which was the ax plus bx to negative 1, no derivative, all over the g squared. So cx minus dx to the negative 2 squared. Man, I've got this headache, will not go away. Usually when I'm doing math, it makes me feel better. Yeah, it's like the opposite today. All right, derivative time. What's derivative of ax? A, we said, derivative of this. So ignore the b, right, because it's a constant. Negative 1 comes down, hits the b and becomes a negative b, x to the negative 2. So negative b, x to the negative 2. Then times this one. Minus, what's the derivative of the next one? C plus 2d x to the negative 3 times ax plus bx to the negative 1 all over, okay, cx minus dx to negative 2. So we were talking about, in one of my other classes, we were talking about, it was my 14 before this, how problems, can start to get kind of long and tedious. So I'll show you something. There's always, everything's relative, right? Where's the one? Trying to find this one particular problem. Which one was it? 7. Number 7. I think this, well, no. No, that looks, there it is. I think that's it. You don't have to, who has to take Cal 2? Anyone have to take Cal 2? Oh, fun. Well, this might be, yeah, I think this is it. Very innocent looking thing, right? So this is the work for it. You'll see, you'll see some stuff in here that's going to look familiar right now, like from pre-cal, sine, cosine. You've seen that before. Look at this right here, right here. What is the derivative of 3/2 sine instead of x theta? Well, 3/2 stays, right? Derivative of sine is cosine. Forget this for now. But see, there's a little derivative right there, just in one little piece of this big problem. And then in here, you have to do some trig identity stuff, like cosine squared is 1 minus sine squared, and then you split it up, and this is cosecant. And then now, okay, we keep going. And now we're using this other technique over here. But look at over here, right here. What's the derivative of cosecant theta? Oh, negative cosecant theta cotangent theta, right? That's just one little piece of a bigger problem. Then you work through all this stuff, more trig identity stuff, blah, 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 blah. Put it together. Now, come in here. Oh, reference triangle, right? You need a reference triangle to put all this back together, right? Remember, sine is opposite over hypotenuse, right? So this triangle represents this equation, and then, boom, and we get the answer. We're done. Yeah, we just did that the other day. So, plus C. The point here is not to intimidate you. It's to, well, we have to keep it all in perspective. Like, if we think that writing a few lines worth of stuff is a big deal, this is a big deal. That's a big deal. 3 or 4 pages worth of work for one problem is a pretty big deal, right? Yeah, one mess up. I don't grade them that way. I don't grade them on. I grade them on, when I grade those problems, is it the appropriate approach? Did you execute the approach? If you made a mistake, did you follow it correctly the rest of the way, right? Like, did you stay within your mistake? Were you still correct? Those are hard to grade. All right. So now look at that. This problem, we're only like half a page, and I'm writing real big. So that's it, right? We're done. Derivative. We could try and clean this up. Let's not. But you could. This times this would be what? ACX. This times this, negative AD over x squared. This times this, negative BC over x. This x would cancel with the 2 x's that were on the bottom from this one. So you just get 1x on the bottom. Again, I encourage you to practice this. It's going to come up later. We just don't have time for that now. All right, we've got 10 minutes. Let me go back to our 2 formulas that we have for today. Where are they? Here we go. These are the 2 big formulas for today, right? We have to, just like we're using power rule today, within the problems, we're using power rule, and we have to be pretty quick with power rule, right? By next class, we want to be proficient with these. We want to be good at these, all right? I told you to memorize these 2, right? There's another way of memorizing it that sometimes is a little bit, I don't know if it's better, but I use both, all right? So that's why I'm showing you. Sometimes I don't look at it as F and G. I look at it as a first function and a second function, right? You have a first function and a second function. So the derivative of a product is the derivative of the first times the second plus the derivative of the second times the first. Sometimes more valuable for you to know it in that way and not be locked into the letters FG. Derivative of first times the second plus derivative of the second times the first. Then the quotient rule becomes derivative of the first times the second minus derivative of the second times the first, same thing, minus though, over the second one squared. Or you could even say derivative of the top times the bottom minus derivative of the bottom times the top, all over the bottom squared. However you want to do it, it needs to just be able to come out of you, right? That you understand the pattern more than you just trying to robot it out. And I've even heard, how does it go? Low-D high, high-D low. How does it go? Yeah, low-D high, less, high-D low. I don't even know how to spell it. High-D, whatever. High-D low over, do you say anything else after that? Over low squared? I've heard this, it's cute. I'm not really into cute things. But it's like, it's something you can see like low-D high, less high-D low, all over low squared. So low is the bottom, high is the top, right? So you've got low D high. This is low. D high is derivative. D is derivative D high. Less, what? High, which is the F. D low, derivative of the bottom. All over. I never learned this. I never learned it because I could never remember, was it high D low or low D high? I just never even adopted it. But I know some instructors are really kind of like push that. You know, like, hey, high D low, whatever. If you like it, go Google it, because I don't even want it to be part of my notes. We're pretty much out of time. Your homework, do everything. No. Do everything here. Page 112. I'm just making sure there's nothing off limits here. That'll be interesting. Don't cry. Are you okay? Very interesting. Okay. Well, you all want to succeed, right? Everyone wants to succeed in this class. And now that you've seen the Cal 2 stuff, you understand it's going to take a lot of effort. 3 through 35. Ooh. All. So there are problems in here, like numbers 27 through 30, where they ask you to find the equation of the tangent line. Well, do you remember what we need for the equation of a tangent line? We need the slope. Well, what's the slope? The derivative, right? So you have to find the derivative first, then you plug in the numbers and you get your slope, and then you use that formula y minus y1 equals m times x minus x1. So putting those concepts back together. We don't want to lose sight of the tangent line. It's going to be here throughout the rest of the class. Number 31 and 32, you can skip part B because they ask you to graph using a calculator. Just don't worry about it. Skip part B. For those two. And then on 33, 34, and 35, you have to find second derivatives. So you have to take the derivative using either product or quotient rule. Then after that, do your derivative again. 3 through 35. Would you all like to see something like that done, or y'all ready to go? You ready? All right, come in prepared next class, all right? Make sure you look at that stuff. Is this my book? Is this my book? Why was I borrowing people's book? I had a book here the whole time? It's been one of those days. All right. What's that? Yeah, I think so.